Hello, so today we are solving the daily challenge of Leetcode. So today's problem is find the student that will replace the chalk. So the question goes like this, that there are n students in a class numbered from 0 to n minus 1. The teacher will give each student a problem starting with the student number 0, then the student number 1 and so on. So they will go in sequentially. After that, the teacher will restart the process starting with the student number 0 again. So that means that once we reach n minus 1, we'll start the process again from the 0th index. You are given a 0 indexed array that is chalk and an index k. An integer k. There are initially k pieces of chalk. When the student number I is given a problem to solve, they will use chalk I pieces of chalk to solve the problem. However, if the current number of chalk pieces is strictly less than chalk I, then student number I will be asked to replace the chalk. Return the index of the student that will replace the chalk piece. Sorry. Okay, so we are given in the example 1 that 5, 1, 5 and k is equal to 2. So as it will go continue until k becomes 0. So first student with index 0 uses 5 chalk, so k is 22, so 22 minus 5. Now it is left with 17. Next one uses 1, so it is 16. Another uses 5, then it becomes 11. So since we reached the end of the array, so we'll start all over again and from 5 and the 0 indexed child again. So it will use again 5 and we will left with 6, then 1, then we will be left with 5, another it will be 0. But it was sufficient for the student, and now the cycle will again go to first student, and here we will find this condition that k is less than that chalk, the number of chalks. So index 0 will be our answer, as the first child, that is the 0 index child, will not be able to solve the problem and he need to restore the chalks. Similarly, for another example, we have 3, 4, 1, 2 and k is 25. So as we see sequentially, we keep on subtracting it and we'll find that the student number, that is the 1 index 1, will not be able to solve it because we won't have enough chalk. So if we see the constraints, n is 10 to the power 5, and if we keep on iterating it until the k becomes 0, so we can't do it because the constraint on k is 10 to the power 9 and we can't do that we can't loop it until we reach k 10 to the power 9. So what we are going to do is that we can just iterate over the array once, and if we try to do something more nested, then we might get TLE. So what I'm thinking is that first we will take the sum of all the chalks that are given in the array. Okay, so I'll start from the first example, 5, 1 and 5, so it is 11, and I'll take k as 22. So what I'll do is I'll take modulus of, I'll take this k modulus of sum, and I'll store that same thing into the k. So what this will mean, that if we have to repeat the process again 10 times, 11 times, 20 times, 100 times, so that part will be reduced and we will be left with that part where k will be less than equal to the sum, or not equal to, less than the sum. And in that case, we know that in that single iteration, when k is less than the sum of the entire array, then we will find that particular index that is causing the issue. So yeah, this is the logic which I will be working on. So let's start with this. I'll take long integer as sum. I'll take it as long because 10 to the power 5 chalks can be, and 10 to the power 5 into 10 to the power 5, and there are n, so this can go to 10 to the power 9. So I'll better take it in long. I will initialize it as 0 and I'll iterate over the chalk array for auto I in chalk. It is sum plus equals I. Okay, and I'll take the k modulus equal sum. So I left with k that will be less than sum. Now I'll iterate over the chalk again for not inti equals 0, I less chalk dot size I plus plus, and here if chalk of I is greater than k, then simply return I, else I'll subtract that chalk I from my k. And since it's a function, I need to return something, so I'll return 0, because otherwise everything will be captured here. So yeah, let's check this. Yeah, this seems to be working fine. I'll submit it. Yeah, it is working fine. It's accepted. So yeah, that's it for today's challenge. See you tomorrow. Thank you.